So understanding factors and multiples is essential when working with fractions. So let's look at the multiplication equation. 6 times 2 equals 12. In this problem, 6 and 2 are factors of 12 because they will divide into 12. 12 is a multiple of 6 and 2 because 12 is in the multiplication tables of 6 and 2. So if you get confused between factor and multiple, just think of the word multiple. Multiple means in the multiplication table. Prime numbers are made, all numbers are made up of a unique combination of prime factors. And remember that prime numbers are numbers that only one in itself will be factors, will be a factor. So for example, if I take 24 and 135 and I use a factor tree to find all the prime factors of each, I find that 24 has the prime factorization of 2 cubed times 3, or 2 times 2 times 2 times 3. 2 cubed times 3 is called the exponential form of the prime factorization of 24. I got it by figuring out all the numbers that will go into 24 using my factor tree. So 8 times 3 is 24, and I could have started with 6 times 4. It doesn't matter. You'll end up with the same prime numbers. I circle 3 because it's prime, and then 8 I have to factor because it's not prime, so it's composite. So 2 times 4 equals 8. I circle 2 because it is prime. 4 is composite, so I have to factor 4, and I get 2 times 2. Both of those are prime, so I circle them. So I end up with 2, 2, 2, and 3 as my prime factors for 24. So that's how I ended up with 2 cubed times 3. And 135, when I factored 135, I ended up with 5 times 3 times 3 times 3, or 3 cubed times 5, is called the exponential form of the prime factorization of 135. No other prime numbers will equal 135 when multiplied except 3 times 3 times 3 times 5, and no other number will 3 times 3 times 3 times 5 equal except for 135. So 135 has this nice, neat, unique set of prime numbers that are multiplied to equal it, that will not multiply to equal any other number. They are unique. So it's kind of neat. Okay, let's review our divisibility rules. So, do you remember your divisibility rule for 2? Anything that's an even number, right? Meaning that if a number ends in 0, 2, 4, 6, or 8, 2 will divide into it. And I have some examples there. 3, do you remember? Add up all the digits, and if they're divisible by 3, then 3 will divide into it. For example, 123, those digits add up to equal what? 1 plus 2 plus 3 is 6. So we know 3 will go into it. And there's some other examples. 4, do you remember the rule for 4? I'll give you a hint. The last 2 digits, they have to form a number divisible by 4. So some examples, 624 ends with 24 as the last 2 digits. 4 goes into 24. 1,316 ends with 16, and 4 will go into 16. 200 ends with 0, 0, and anything goes into 0. What about 5? That's an easy one, right? If the number ends in 5 or 0, then 5 will divide into it. What about 6? For 6, you have to check the number to see if both 2 and 3 will divide into it. Check both of those rules. For example, 912. 9 plus 1 is 10, plus 2 is 12. Well, 3 goes into 12, so it's divisible by 3. And the last digit is a 2, which means it's an even number, so 2 will go into it. We're going to skip 7 and 8. How about 9? Do you remember that rule? It is the same as 3, except you have to be able to divide the sum of the digits by 9. So, for example, 639. 6 and 3 is 9, plus 9 is 18. So I know that 9 will go into 639. And then our last is the easiest rule of all, and that's dividing by 10. What do we have to have as our last digit? A 0. So those are pretty easy. All right, the next thing we're going to talk about is the greatest common factor. The greatest common factor is a number that 2 numbers have in common as factors, and it's the biggest one. So the old-fashioned way that you guys have learned to do this is with the listing method. You take two numbers and you list all their factors, and then you circle the biggest one they have in common. And this is great when you're dealing with small numbers. It's the easiest way to find the GCF. But of course, we're not going to be dealing with small numbers, so I'll be teaching you another method. But let's just review what the GCF actually is. It's the largest factor two numbers have in common. Then we have LCM, least common multiple. The least common multiple, that's the smallest number that two numbers share in their multiplication tables. Again, remember multiple for multiplication tables. Okay? And L is the least common multiple. So, for example, with 6 and 8, we're looking at the multiplication tables of 6 and 8. So if we list those out, the first number we get to that they have in common in their multiplication tables is 24. So now what we're going to do is look at a technique that's really helpful when you're dealing with big numbers to find the LCM and GCF. And finding the least common multiple is the same as finding the least common denominator with fractions. Finding the GCF is how you figure out the fastest way to simplify a fraction. So these are very, very important skills for fractions. So guess what we're going to use? We are going to use prime factorization. So we're looking at an example of 108 and 90, and we want to find the greatest common factor and the least common multiple of these two numbers. I used my prime factorization trees to figure out the prime factorization for each of these numbers. For 108, my prime factorization is going to be 3 times 2 times 3 times 2 times 3. So that's going to equal, I have 2 2's and 3 3's, so 2 squared times 3 to the third. For 90, I have a 3, a 3, a 2, and a 5. So 90 equals 2 times 3 squared times 5. So now I'm going to use what's called a Venn diagram to figure out my GCF and LCM. The first thing I'm going to do is find all the numbers that they have in common and write those right here in the middle of my Venn diagram. So they both have a 3 in common, so I'm going to write a 3 in the middle. They both have another 3 in common, I'm going to write another 3. They both have a 2 in common, I'm going to write another 2. Do they have anything else in common? No other prime factors in common. So now I need to complete each circle. 108 has the factors of 3, 3, and 2, but I also need this other 2 and this other 3, so I'm going to include those in the black circle. And then in the green circle, I already have my 3, and my 2, but I need to include my 5, so I put my 5 in the green circle. Notice I don't want to write down the 3, and the 2 that are in the middle. I don't want to write them twice, only once. That makes sure that I get the least common multiple instead of the just a big multiple. Okay? So the greatest common factor is going to be the middle numbers, 2 times 3 times 3, that I have written in red there, which is 2 times 9, which is 18. Then for the least common multiple, I'm going to multiply everything together that I see there in my Venn diagram. So I'm going to multiply the 2 times the 3. I'm going to multiply the 3, and the 2 from the middle. I'm going to multiply the 5 from the green circle. And all together, this equals 540. And you are welcome to multiply your least common multiples, prime factors, together on a calculator, however you are expected to show all of this work. So let's look at this next example of 72 and 90. For 72 and 90, we have the prime factorization of 72 equaling 2 cubed times 3 squared, and the prime factorization for 90 of 2 times 5 times 3 squared. So now I'm going to find all the numbers they have in common. So they have a 2 in common, I've marked out in red and written it in the middle of my Venn diagram. They have 2 3's in common, I've marked those out in red and written those in the middle of my Venn diagram. So my greatest common factor is the 2 times the 3 times the 3 in the middle there, which gives us 18. Now for the least common multiple, I need to fill in all the numbers for 72 in the black circle and for 90 in the green circle. So for 72, I had 2 cubed times 3 squared. Well, I have 1 2 here, but I need 3. So I'm going to put the other 2 in the black circle. And then for 3 squared, my 3 squared is already written over here in red, so I have everything I need for 72. And I'm going to double check. I have 3 2's and 2 3's, so 72 is covered. Now I'm going to look at 90. Well, for 90, I need to have a 2. Well, I have a 2 in the middle. And I need a 5. Well, my 5 is missing, so I'm going to write that in the green part of my circle. And then I need 2 3's, which are both in the middle already, so I don't have to write those down. So now to find the least common multiple, I'm going to multiply everything I see here in the 2 circles and the middle. I'm going to multiply all that together to get my least common multiple. So I'm going to multiply the 2 2's from the black circle, the 2 and the 2 3's from the red part, which is the greatest common factor, and then the 5 from the green circle. I'm going to go ahead and multiply all those together using my calculator, and I find that the least common multiple is 360. Next, you're going to find the LCM and GCF of 2 numbers that are already written in exponential form for you. And you're asked to leave the answer in exponential form. And what that means is you don't actually multiply the answer out, so it's really less steps. You don't have to do the prime factorization tree, and you don't have to multiply your answer out. You just put the answer down in exponential form. So I'd like you to go ahead and pause the video, put all the factors they have in common in the middle, put the leftover factors for the first number in the black, the leftover factors for the second number in the green, and then write out your GCF's prime factorization and your LCM's prime factorization, and let's see how you do. You should end up with a 2, a 3, a 3, and a 5 in the black circle, a 2, a 3, a 3, and a 7 for the overlapping part of your Venn diagram, and a 7 for the green part of your Venn diagram. So let's double check where this comes from. For the black, we have to have 2 2's, so let's look first at what they have in common. So what they have in common is they have 1 2 in common, so I'm left with a 2 there. They have 2 3's in common, so I'm left with 3 squared there. They have 2 7's in common, so I'm left with 1 7 there. So they have a 2 3's and 2 7's in common, and then we're left with 1 7 for our green circle. So let's go ahead and multiply 2 times 3 times 3 times 7 times 7 to get the greatest common factor, and that gives you 2 times 3 squared times 7 squared. And remember, you don't have to multiply it all the way out, which is great, right? And then for the LCM, we're putting together the 2, the 3, the 3, and the 5 from the black circle, the 2, the 3, the 3, and the 7 from the overlapping part, and the 7 from the green circle, everything in the entire Venn diagram, and we end up with 2 squared times 3 to the 4th times 5 times 7 cubed.